In the last video, we saw the no cloning theorem, which says that we cannot copy any arbitrary quantum state. In this video, we will see how to take a state from one place to another without copying it. So, quantum teleportation is a technique for moving quantum state around even in the absence of a quantum communication channel, linking the sender of the quantum state to the recipient. Now, in order to understand how quantum teleportation works, let's see the case of Alice and Bob. So we have two people, Alice and Bob, and when they lived together, they created an EPR pair beta 00. After a while, they were living apart, where each took one qubit of the entangled state beta 00 with them. Now, Alice wants to deliver a qubit psi to Bob, but she doesn't know the state of the qubit psi, and moreover, she can only send classical information to Bob, that is in bits. And even if she did knew the state psi, describing it precisely through a classical channel would take infinite amount of classical information, and it would take Alice forever to describe it precisely to Bob, since psi takes value in a continuous space. Fortunately, with the help of quantum teleportation and her entangled EPR pair beta A, she can send psi to Bob with a small overhead of classical communication. Now, this circuit describes our process of quantum teleportation. Here, the single lines represents quantum information channel in qubits, and the double line represents the classical information channel in bits. Here, M1 and M2 are the measurements that Alice takes, which turns the information to classical bits, which she can communicate with Bob. Here X and Z are our quantum gates, which Bob will use to generate psi after getting the classical information from Alice. We have divided this circuit into four states, that is psi 0, psi 1, psi 2 and psi 3. Also, we have taken psi, that is the information that is to be teleported, to be a generic state with alpha 0 plus beta 1. So now let's see how to get each of this state in this circuit. Let's see the state psi 0. Here Alice and Bob, both having single qubit, creates an EPR pair beta 00 with the help of the Hadamard and the C0 gate. So the first qubit is operated by the Hadamard gate and then tensor product with the second qubit, and this state is then operated by the C0 gate to give us an EPR pair 00 plus 11 divided by root, which is our state psi 0, as you can see from this diagram. Now this entangled state is shared by Alice and Bob, and when they get separated, each take one qubit of this entangled pair. Here the second line is the Alice state and the third line is the Bob state. Now till the state psi 0 they were together, and now they are separated. To send the information to Bob, Alice has to do a series of operation with the state psi to generate the classical bits. Now let's see how we get the state psi 1. From this diagram we can see that psi 1 is the tensor product of psi with psi 0 corresponding to the Alice qubit. Therefore, psi 1 will be equal to psi 0, which will be equal to, since psi is alpha 0 plus beta 1 and psi 0 is 00 plus 1 divided by root 2. And when we multiply this, we get alpha 000 plus alpha 011 plus beta 100 plus beta 111 divided by root 2. After getting the state psi 1, now the first two qubits of the state psi 1 will be operated by the C0 gate. This operation of C0 gate on psi 1 will give us psi 2, where the qubit 1 of psi 1 will be acting as the control qubit and the qubit 2 of psi 1 will act as a target qubit. So by operating C0 on psi 1, we get when the control qubit was 0, the target qubit was left alone. We are not concerned with the third qubit. Similarly, for the second case, when the control qubit was 0, the target qubit was left alone. But in the third case, since the control qubit is 1, the target qubit is flipped from 0 to 1. And in the fourth case also, since the control qubit is 1, the target qubit is flipped from 1 to 0. And in this fashion, we get the state psi 2. Now from the diagram we can see that the first qubit of psi 2 is operated by the Hadamard gate, which will eventually give us the state psi 3. So let's see how it works. So in order to get psi 3, the first qubit of psi2 will be operated by the Hadamard gate. This operation will give us this equation, where the first qubit when operated by the Hadamard gate will give us 0 plus 1 by root 2 for 0 qubit and 0 minus 1 by root 2 for 1 qubit. And by multiplying this again in the bracket, we'll get this equation. Also, this 1 by root 2, and by taking all the 1 by root 2 outside, we get the coefficient half. Now, if we simplify this by taking the first 2 qubit common, which corresponds to Alice's qubit, and the third one of Bob, we get psi3 equal to half 0 0 alpha 0 plus beta 1 plus 0 1 alpha 1 plus beta 0 plus 1 0 alpha 0 plus minus beta 1 plus 1 1 alpha 1 minus beta 0. One more thing with psi3 state is that it is a linear combination of these four states with coefficient half. So the probability, that is the square of psi3, of getting any one of these states will be 1 by 4. Now after getting the state psi3, Alice is ready to measure her qubits. We can show these measurements with this table, and the results of these measurements can be communicated by Alice to Bob later to give the state psi. So from the measurement, if Alice's get 0 0, then the resultant state would be alpha 0 plus beta 1, that is this state. So now Bob does not have to do any operation on this state in order to get psi, since psi is also alpha 0 plus beta 1. That means Bob will not perform any of the operation by the X gate or the Z gate in order to get psi, that is represented by this equation. Similarly, if Alice gets 0 1, then the resultant state would be alpha 1 plus beta 0 from the psi 3 state. And in order to get psi, Bob has to operate this state with the X gate, which is given by this equation. Similarly, if Alice gets 1 0, then the resultant state is alpha 0 minus beta 1, which is this state. And after communicating this with Bob, Bob can perform this operation on this state in order to get psi. And finally, if Alice gets the classical bits as 1 1, the resultant state would be alpha 1 minus beta 0. And after communicating these bits with Bob, Bob can perform this operation with this state in order to get psi. Finally, we can write the state psi 3 in a more condensed form as this equation, where all the four states are represented in terms of psi when operated by these gates. Here one thing to note is that we have xz operating on psi, which will give us alpha 1 minus beta 0, which is this state. But for Bob to get psi, he needs to operate x first and z later on this state. This implies that ordering matters, since Z and X are matrices. So finally, Alice was successful in teleporting this state psi to Bob with the help of few classical information. So this was the process of quantum teleportation. I hope you understood it. So in order to study these topics in much more detail, I am referring to this book of Quantum Communication and Quantum Information by Nielsen and Shaw. You can refer to this.